Hi, and welcome to Conics Day 2. Today we're going to talk about ellipses. So ellipses are oval in shape. They have two foci where the total distance is always the same. So D1 plus D2, no matter what, will still equal like D3 plus D4 here. The total distance is always the same. So we get a couple key points. We have the center. We have a major axis and the vertices on each of those. We also get a secondary minor axis, and these coordinates right here as well, we'll talk about here in a bit. So the coordinates, our foci are always C units away from the center. So from foci to foci, we get a distance of 2C. We get these equations for horizontal and for vertical, talking about the major axis. Now that just means which way it's stretched more. One thing to notice, A is always greater. So if X is with A, it's stretched more horizontally. If Y is with A, it's stretched more vertically. And we also get this relationship that you're going to need to know, C squared equals A squared minus B squared. One thing that tricks kids is this minus, because you want to think it's a Pythagorean theorem, but it's not. So, vertices. Vertices are always minus A and plus A. And they're, again, always on the major axis. Which means this is a distance of A. So if I just had the graph, I could figure it out that way as well. Co-vertices are on the minor axis and are always adding and subtracting B. Which means this distance is a distance of B. And foci are from 1 to there, adding and subtracting a distance of C. So today you're going to need 5 different coordinates, or 5 different values, H, K, and A, B, C, in order to find all the values. Horizontal is the same, but flipped. So if we consult our formula sheet, we see that they get flipped for every coordinate that you need. So first, I should look which fraction, or sorry, which denominator is bigger. Obviously, the 25 is bigger, so my x is with my a. So because x is with my a, it's stretched more horizontally, so this is actually a horizontal ellipse. So now let's find our h, k, a, b, c. So just like yesterday, h is whatever I'm subtracting from x. I'm not taking away anything from x, so I get a 0. Y or k is whatever I'm subtracting from the y, so that's 0. A, well, a squared equals 25, so a has to be 5. And b squared has to be 16, so b has to be 4. And then we can use our relationship. C squared equals a squared minus b squared. 25 minus 16, c squared is 9, therefore c is 3. Otherwise, now I can just find the value. So starting first, my center is HK, which means 0, 0. My vertices are going to be H plus and minus A, comma K. Well, H is 0, A is 5, so I'm going to get 0 plus 5, so 5, 0. And 0 minus 5, so negative 5, 0. My co-vertices, as we talked about earlier, are H, comma, K plus and minus B. So 0 is my H value, that's going to stay. K plus B, so 0 plus 4 is 4. K minus B, so 0 minus 4 is negative 4. Of course, we get our foci. Our foci, h plus and minus c, comma, k. So 0 plus 3 is 3, 0 minus 3 is negative 3, k is 0 for both. We get the major axis is going to be y equals 0 because there more coordinates are on. We get the minor axis is going to be x equals 0. And then we can connect our ellipse with our vertices and co-vertices. So something like that. Over here, same process. Which denominator is bigger? This one. So the a has to be with the y, and therefore this is vertical. H, what am I subtracting from x? 0. K, what am I subtracting from y? 0. A, well, a squared is 36. So therefore a is 6. B squared has to be 4, therefore b is 2. And then, of course, c squared equals a squared minus b squared. So c squared equals 36 minus 4, so 32. So c is the square root of 32. Because we're eventually going to add it, I'm going to do a quick rough estimation. And I'm just going to do 5.66. 5.7 is good enough for me. Normally, I wouldn't do a lot of rounding, but I just don't want to keep track of all the radicals. If you want to do instead something like 4 square root 2, feel free. But I'm just going to do some rounding because I have to add a coordinate. All right. So that was C. So center. Center is always HK, so we're going to get 0, 0 we can plot. Because this is vertical, we can now find vertices are going to be h, comma, k plus and minus a. So a plus 6, there's 0 plus 6 and 0 minus 6, so I'm going to get 0, 6 and 0, negative 6. Okay. Co-vertices h plus and minus a, comma, k. So, sorry, a plus and minus b. Co-vertices is b. 0 plus 2 is 2. 0 minus 2 is negative 2. And my k stays the same from earlier, so 2, 0 and negative 2, 0. My foci, which are going to be h, comma, k plus and minus c. So we're going to get 0 for my h values. 0 minus 5.7, so negative 5.7. 0 plus 5.7, so positive 5.7. Major axis, where most of my points, they're along this x equals 0 line. Minor axis, where my other points on this y equals 0 line. And then connect my vertices and co-vertices. You should always notice your foci are always inside or closer than your vertices, which should make sense because c squared, by definition, is a squared minus b squared. So a squared always is the biggest between the three of them. Here, the one weird thing is this one doesn't have a fraction. I can put it over 1. That's perfectly fine. So looking at the denominators, I can see that the 16 is naturally bigger. So that is with my y value. So I'm getting stretched vertically. So h. What am I subtracting from x? That'd be 1. K, what am I subtracting from y? That'd be negative 3. A, well, a squared is 16, so a has to be 4. B squared has to be 1, therefore b is 1. And if I find c, 16 minus 1 is 15, so c equals the square root of 15, which is let's go with 3.9. But from there, it's just fill in the spots. So center, HK, so 1, negative 3. We get vertices. So because it's vertical, that'd be H. So H stays the same for both. And then it's K plus or minus A. So negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Co-vertices, we're going to get as H plus or minus B comma K. So the K stays the same. So we're going to get 1 plus 1. That's going to give us 2. And we're going to get 1 minus 1. It's going to give us 0. Foci, that is, if we remember, H comma plus or minus, I'm sorry, K plus or minus C. So my H stays the same. So I'm going to get 1 for both of those. Negative 3 plus 3.9, that is 0.9. Negative 3 minus 3.9, that's negative 6.9. Major axis is going to be x equals 1. Minor axis is going to be y equals negative 3. Then, of course, we can connect these the parabola. Next one, I can again see that this is going to be vertical because my biggest denominator is with the y. So h, what am I subtracting from x? Nothing. What's math nothing? That's 0. K, what am I subtracting from y? That'd be 2. A, my biggest denominator is square root. So if a squared is 16, a has to be 4. B squared has to be 4. So what does b have to be? B has to be 2. And if c squared equals a squared minus b squared, 16 minus 4 is 12. If c squared is the square root of 12, that's the same thing as 2 root 3 if you like exact radicals, or just for the sake of today, we'll say about 3.5. From here, you would just plug in all those values and plot it. For the sake of brevity, we're going to skip the rest of that, but that's how you would go about that process. Here. I would look at these and notice that my h's stayed the same. So because this is vertices, I'm going to look at my vertices formulas and see which one affects the y value. Well, looking here, k plus or minus a for the y value makes this a vertical ellipse. So this is going to be vertical because these are h comma k plus or minus a right there. So I need to write an equation, which means I'll need h, k, a, and b. Technically speaking, you don't need c because c is not part of the equation. Unfortunately, we're going to have to solve for c later during this process. So I'm sorry about that. Okay, now let's think about this. H comma K by definition is our center. We all agree that H is going to be 2 because that value didn't change. So K has to be my centered Y value. So there's two ways you can conceptually do this. You could say that I could do K plus A equals 4 and K minus A equals -2 and write them as a systems of equations. That would technically work where I add both these together. I'm going to get 2K equals 2, and therefore K equals 1. I'm going to tell you right now, K is 1. Absolutely. Or you could recognize that K is the Y center, which means K has to equal the average of both those values. It has to be right in the middle. So -2 plus 4 be +2 divided by 2 still gives us K equals 1. From there, I can just understand that if K equals 1, therefore A has to equal 3, because, for example, 1 plus 4, or 1 plus 3 equals 4. Okay. All that should make sense. Minor axis. Well, minor axis is kind of tricky. Let's go back a slide here. The minor axis, we'll notice, is a distance, the total from covertice to covertice, which means, therefore, when I'm talking about the minor axis, that has to equal 2b. So therefore, 4 equals 2b, b equals 2. So because it's vertical, I can do x minus h squared over b squared plus y minus k squared over a squared equals 1, and plug in all those values. So x minus 2 squared over 4, because that's what 2 squared is, plus y minus 1 squared over a squared, 3 squared, so 9. Okay. Same idea over here. I can notice that my h stayed consistent here, so this is k plus and minus c. So I would look which one of my sets of equations has plus and minus c in the k value. Well, that means this one is going to be vertical again. So let's identify our h, k, a, b, c. Well, h has to be 0, and k has to be the average of 0 and 8. Again, if you want to do systems of equations, it also works. So we get k equals 4. So what would I add and subtract of 4 to give me 0 and 8? Well, c then has to be 4 by that logic, because 4 plus 4 gives me 8. I can then look at this major axis length. If I go back a slide again, I could recognize major axis is yellow. That's distance from center to vertex, aka the total distance is that thing. But if I remember that center to vertex is just a matter of a, which means major axis length has to equal 2a. So 16 equals 2a. Therefore, a is 8. And I need to solve for b. I can't solve for b any other way but besides using a squared minus b squared equals c squared. So the 8 squared minus b squared equals 4 squared. Do some quick math. B squared equals, what is that, 48? Let's find out here. 64 minus 16. Yeah, 48. So b equals a square root of 48, but I don't actually care about b because what I need for the equation is b squared. So we get x minus 0 squared, so just x squared, over b squared, so 48, plus y minus 4 squared over 64 equals 1. Thank you for listening, and I hope you have a great day.